In this lesson we'll look at how to transpose a formula, otherwise known as changing the subject of a formula. The basic idea to be aware of in anything like this is if you're manipulating a formula, whatever you do to one side of a formula you must do the same to the other side, and you're familiar with that from junior psycho. So for example, you can add or subtract to both sides of a formula. You could multiply or divide both sides of a formula. You could square both sides, or you could take the square root of both sides. And there are a number of other examples of what you can do also. So rather than cover every single one, just simply remember the basic rule in the center. As a very simple example, say you have A is equal to B plus C, but you want to make B the subject of that formula, i.e. you want B on its own on one side, everything else on the other side. Now, something like this you may do automatically, but it's very important to remember what it is you're doing at each step. So let's say you wanted to leave B on its own there. You need to get rid of the C from this side. So essentially you are subtracting C from the right hand side. So C is gone from the right hand side, but you must also subtract C from the left hand side. So you have B is equal to A minus C. Of course, you could write it like that also. As another very simple example, let's say you have AB is equal to C. Again, this is something you may be doing automatically at this point, but let's say again you want to make B the subject of that formula. What do you need to do? Well, you need to get rid of the A from the left-hand side. Because A is multiplied by B on the left-hand side, you need to divide the left-hand side by A, which will give you B. But because you've divided the left-hand side by A, you must also divide the right-hand side by A, so you get C over A, or C divided by A. So let's gradually increase the difficulty level. Let's say you have something like this. 2B minus C over 3 is equal to A. A good approach in any question involving fractions is to initially try and get rid of all the fractions. It will make your life a lot easier. So if you want to get rid of this 3, you can see that the 3 is divided into the top. To get rid of a division, you need to multiply. So you multiply both sides by 3. If you multiply the left-hand side by 3, you simply get 2B minus C. Multiply the right-hand side by 3 also gives you 3A. It's better to think of it like that rather than to think of ideas like cross multiplication, which you might be very familiar with, but it's important to understand why you can do it if you're doing it. Now in this case we want to have B on its own on the left, so the first thing we need to do is get rid of the minus C from the left. If you want to get rid of a minus, you have to add C to both sides. So if we add C to the left hand side, we simply get 2B. Then add C to the right hand side, you get 3A plus C. And finally, because we just want B on the left hand side, we have to divide the left hand side by 2. So we divide everything by 2. So we get B on the left hand side, and then on the right hand side we get the entire thing divided by 2. Now let's take this example. We want to isolate C on its own. Now notice again this is an equation involving fractions, so the first thing to do is to try and eliminate the fractions. So to do that we multiply each term by C. So we get AC. Now if you multiply minus B over C by C, you simply get minus B, but then we multiply the right hand side by C also, in which case we get CD. Now, because it's C that we want, we need to have every term involving C on its own on the left hand side. So we already have AC on the left hand side. This term is on the right hand side. We don't want anything involving C on the right hand side. So we simply subtract CD from both sides. So on the left we get AC minus CD. We don't want the B on this side, so we add B to both sides. So on the right hand side you will get b, and because we have subtracted CD from the left hand side, we must also subtract CD from the right hand side, so this CD is gone from the right hand side. In order to isolate C on its own, we now need to take out C as a common factor on the left hand side, and it comes out A minus D times. And finally, because C is multiplied by A minus D on the left, we need to divide both sides by A minus D. So C is equal to B over A minus D. So increasing the difficulty a little bit more, let's take this example here where we want to isolate R on its own. Now, in this case we've got fractions again, so a good idea is always to try and eliminate the fractions. So the technique for eliminating fractions is to multiply each term by the lowest common multiple of all of the denominators that are present. So if you look at the denominators in your equation, or your formula, you've got a q there and an r there. So we multiply each term by the lowest common multiple of q and r, which is of course qr. So we multiply everything by qr. So multiplying that by qr, and that by qr, and that by qr. Now, when you become more familiar with this kind of technique, there will be no need to write out that particular line explicitly. But you'll see what happens. In the first term here, if you multiply above and below by q, or essentially what's happening is the q's are cancelling. Over on the right hand side, r will divide into r once. So straight away you have eliminated all fractions. So what you're left with on the left is p times r. On the right, what you have is q times q, which is q squared, and then you've got m q r. So remembering that r is what you're looking for, we need every term involving r on the left hand side. So we subtract this entire term, mqr, from both sides. So pr is already on the left. We're subtracting mqr from both sides. We're left with q squared on the right hand side, and because we've subtracted mqr from the right hand side, there is nothing else left on the right hand side. As we did in the last example, the thing you're looking for you now take out as a common factor on the left hand side. So r comes out as a common factor times p minus mq times, and that's equal to q squared. And then the final step is to divide both sides by p minus mq. So you're left with r on its own on the left. On the right you've got q squared over p minus mq. So let's take this as a slightly more difficult example. In this case we want to isolate c. The normal principles apply. We want to get rid of fractions from both sides, so we multiply both sides by the lowest common multiple of all the denominators. Now in this case there's only one denominator, it's b plus c. So we multiply both sides by b plus c. So on the left hand side you get a times b plus c. On the right hand side, because you've multiplied it by b plus c, the b plus c's will essentially cancel. You're left with b squared minus ac. Now, just to be totally clear, when I say cancel, you may end up writing it like this, but it's very important that you understand what's happening. You're essentially dividing b plus c into b plus c, in which case you get 1. 1 multiplied by anything is itself. So just be careful when using terminology like cancelling that you understand exactly what it is you're doing. Now, looking at what we have, and bearing in mind that we want to isolate c, we will need to get every term involving c on the left hand side. So you should see that you will need to multiply out the left hand side. A times b will give you ab. You won't want that on the left hand side, but you will have a times c. So just multiply out the left hand side. So on the left you get ab plus ac. Now we need to get every term involving c on the left, so we will need to get rid of the minus AC from the right, which of course means we have to add AC to both sides, and we will need to get rid of AB from the left, which means we will have to subtract AB from both sides. That will give us AC, and again remember we're adding AC to both sides, plus AC equals B squared. Now we've added AC to both sides, so this AC has now disappeared, but also remember we're subtracting AB from both sides, so we have a minus AB on that side. Now on the left you'll see that AC plus AC is 2AC equals B squared minus AB, and on the left hand side now what you have is 2A multiplied by C. You want to get rid of the 2A, so you divide both sides by 2A, leaving you with C equals B squared minus AB over 2A. Now, this particular formula here should be familiar to those of you studying physics or applied maths. It's to do with the periodic time of a simple pendulum, where T is the periodic time, K is some constant, L is the length of the pendulum, and G is your acceleration due to gravity. In this case anyway, we're just trying to isolate L on its own on one side. So where you have a square root on one side, you will need to square both sides. Now, just remember in general, if you've got two terms multiplied, and if you square them, that's the same as squaring each term individually. Now the reason we say this is, on the right hand side you've got two terms multiplied. You've got K multiplied by the square root of L over G. So if you square the right hand side, you can square each of these individually. But of course you must also square the left hand side. So on the left you get T squared. On the right hand side, because the terms are multiplied, you can square each term separately. K squared, and if you square the square root of L over G, you simply get L over G. Now remember as well, if you've got something like A times B over C, that is AB over C. The common mistake might be to say that it's AB over AC, but just remember that A is the same as A over 1. When you're multiplying fractions, you multiply the top by the top and the bottom by the bottom, so A multiplies by B and 1 multiplies by C. The reason I say this is because you've got something similar here. Consider this as being K squared over 1. The K squared multiplies by the L, and you're left with the G on the bottom. So that's the same as saying T squared equals K squared L over G. Now, what you want is L on its own on one side, everything else on the left. If you want to make it simpler, you could write this around the other way. K squared L over G equals T squared. Now, you want to get K squared eliminated from the left, so you will need to divide both sides by K squared. You want G eliminated from the left, so you'll have to multiply both sides by G. So in doing so, you'll be left with just L on the left-hand side. Now remember, we're dividing both sides by K squared, multiplying both sides by G. So on the left you get, on the right you get GT squared over K squared. Now, just to make it totally clear what we did there, you've got your K squared L over G equals T squared. We have divided both sides by K squared, and we have multiplied both sides by G. So you eliminate the G's from the left, and you eliminate the K squareds from the left, leaving you with just L on the left, and then T squared times G over K squared on the right. This is another formula that should be familiar to those of you doing physics. So as with any equation formula involving fractions, we first of all try and eliminate the fractions. So as we did before, we multiply each term by the lowest common multiple of the denominators. If you look at the denominators there, they are P, Q and R. The lowest common multiple is P, Q, R. So we multiply each term by P, Q, R. So as you see, what will happen is P will divide into P, Q will divide into Q, and R will divide into r, leaving you with, here you'll have QR, here you'll have PR, and here you'll have PQ. So QR equals PR plus PQ. So straight away you have eliminated the fractions. Now let's say in this case we're asked to isolate r on the left hand side. So each term involving r needs to come to the left. QR is already there. We subtract PR from both sides. So the PR is gone from the right, so you just have PQ left on the right. As before, we take the r out as a common factor on the left. Q minus P times equals PQ, and then we divide both sides by Q minus P.